This podcast is brought to you by Enlightening Learners Academic Coaching and Tutoring Service.
In this presentation, we're going to solve inequalities involving absolute value. Your questions: what are the steps for solving an absolute value inequality, and what are the clues for determining if the graphs run away from each other or towards each other? So we've got an absolute value, and this absolute value is x is less than 5. Okay, so essentially what's going to happen is we're going to split this. Every time we have this equation, we're going to split it into two equations. We're going to split it into its positive side and its negative side. Now when we split it into its positive side, we don't do anything with the inequality. Notice that it's still running, running to the left or pointing to the left. But when we split it into its negative side, we change the inequality direction and we make this number a -5. Now, this says x is less than. If you notice, it's kind of a pun on words, but less than really means less than. And less than graphs are going to run towards each other. Okay, so let's graph this. If we're going to number line here, we split it into its positive and negative. X is less than 5, and here's my, and x is greater than -5. So my dots are both open. Here's my 5, here's my -5. It's an open dot on both of them. Less than 5 runs in that direction. Greater than runs that direction. So whenever you see an inequality less than, and it's just dealing with absolute values, we know that they're going to run towards each other. As opposed to this equation, it says greater x, the absolute value of x is greater than 5. Greater is another pun on words, greater, or it's an or. And essentially what that means is that the graphs are going to run away from each other. So let's go ahead and take a look at this. Again, we take the value and we split it into its positive and its negative. And when we find the negative value, we change the direction of the inequality. So again, if I'm going to graph this on a number line, I've got a 5 and a -5, so I'm going to put my -5 to the left and a 5. And they're both open dots once again. X is greater than 5, runs in that direction. X is less than -5, runs in that direction. Okay, so let's take this and make it actually into an equation. So what I'm going to do is I'm going to split this into its positive and negative, and as I split it, I'm going to lose my absolute value brackets. So the positive realm is m plus 1 is less than 5, and then my negative value is m plus 1. I got to change the direction, a -5. So I can solve both of these at the same time by doing the same property. And in this case, it's just a one-step equation. I'm going to subtract 1 to everything. These cancel like they're supposed to. And then I simplify. M is less than 4. And M is greater than -6. If we're going to graph these, I've got a 4 over here. On my positive side, I have a 4. On my negative side, I have a -6. M is greater than -6. It's an open dot. runs to the greater than direction. M is less than 4 is an open dot and runs to the less than direction. So we've got one more equation here. We're going to split it into its positive and negative realm. I'm going to rewrite the equation without the inequality brackets. Without the absolute value brackets. And in this one, my negative side, I'm going to go ahead and flip it and then make this a negative 12. So once again, I can do it all at the same time. What I do to one side of the inequality, I do to the other. 12 plus 12 is 24. So I'm left with 3x is less than 24, and 3x is greater than 0. But when I divide this both sides by 3, I get x is less than 8 and x is greater than 0. My dots are both open again. Here's my 0. Here's my 8. Both dots are open. X is less than 8. Runs in that direction. And x is greater than 0. Runs in that direction.